let's talk a little bit about random variables, which is a topic we'll come back to time and again throughout this course. So first we'll define a random variable and we'll take a look at an example, and then we'll briefly talk about uniform random variables, and finally we'll remind ourselves that random variables are neither random nor variables, but they're actually functions. So a random variable is an assignment of a numerical value to each of the outcomes in a sample space. We've talked about that before. Just to remind ourselves, a couple of examples. Suppose you roll two six-sided dice. One way to assign a value to each outcome would be to assign the sum of the two faces showing. Another way to assign a value to each outcome would be to assign the maximum of the two sides showing. So there's two different random variables for the same random experiment. Here are a couple of tables that express these assigned values. On the one on the left, the vertical axis is the value shown on one die, the horizontal axis at the top is the value shown on the other die, and then in the table we have the sum of the two values. So if we want to know the probability that we get a value assigned of 6, we just count how many 6's occur in the table, and you can see 5 of them there, so it would be 5 divided by 36. In the example on the right, we do the same thing, except instead of adding the two values, we just record the one that's bigger. The book talks about the first example in some depth, so I'll talk about the second one. We can now express the probability of getting an assigned value using a table such as this. So the probability of getting an assigned value of a 3, for instance, in that table, 3 occurred 5 times, where we rolled a 3-3, or a 3-2, or a 3-1, or a 1-3, or a 2-3. And so 5 out of 36 outcomes had the value 3 assigned to them, so the probability that we get the value of 3 for our random variable would be 5 divided by 36. So we might ask whether this is a uniform random variable. In order to answer that question, well, we have to define a uniform random variable. So a uniform random variable is a random variable on a finite set of outcomes S, such that the probability that x equals S of I is equal to 1 over k. And so in this case, we have k possible outcomes, each equally likely and assigned a probability of 1 over k. Well, if you think about our example with the dice, we had 36 possible outcomes, each equally likely, assigned a probability of 1 over 36. So yes, that was a uniform random variable. It's worth noting here again, random variables are not random, they're not variables, they're functions whose domains are the sample spaces to which they assign values. It's also worth noting that we're often sloppy in our notation. So for instance, with the die roll, if we're rolling two six-sided dice and recording the maximum value, we'll often say, what's the probability of a 5, rather than saying, what's the probability that x equals 5. But by both of these, we mean typically the same thing. Context usually shows what we mean by that.